morning children. Yesterday we have studied about some methods for the preparation of carboxylic acids. Do you remember the methods? Today let us continue with the class. That is, the next method for the preparation of the carboxylic acid is from alkene. That is, ethene undergoes heating with a mixture of carbon monoxide and steam in presence of dilute sulfuric acid or phosphoric acid and produces monocarboxylic acid. Is it clear? Ethene undergoes reaction with or it undergoes heating with a mixture of carbon monoxide and steam in presence of sulfuric acid or phosphoric acid and produces monocarboxylic acid. Next method we can consider from sodium alkoxide. Okay, from sodium alkoxide. Sodium alkoxide on reaction with carbon monoxide in presence of heat and under pressure you will get sodium salt of carboxylic acid, which on acidification produces carboxylic acid. Okay, sodium alkoxide reacts with the carbon monoxide in presence of pressure and heat and produces sodium salt of carboxylic acid, which on acidification will give you carboxylic acid. And the last method we can consider by the oxidation of alkyl benzene. That is, for example, if you consider methyl benzene undergoes oxidation in presence of strong oxidizing agents like alkaline KMnO4 or acidified K2Cr2O7 and produces benzoic acid. Children, whatever be the length of this alkyl chain, in presence of strong oxidizing agent, it produces again benzoic acid. Is it clear? That is, instead of methyl benzene, if we take ethyl benzene, if you take ethyl benzene, that also on oxidation will give you benzoic acid. Is it clear, children? That is about the method for the preparation of carboxylic acid. Now let us study about the physical properties of carboxylic acid. Okay, we are going to mention about physical properties of carboxylic acid. In physical properties, first let us discuss about state. That is, if you just consider this carboxylic acid up to 10 carbon atom generally exist in the liquid state. That is, the first 10 members of carboxylic acid you can see in the liquid state, and the higher members you can see as waxy solids. Is it clear, children? That is, when you discuss about the state, you can see that the first 10 members generally exist in the liquid state and the higher members exist as waxy solids. And at the same time, we can see that the first 3 members of carboxylic acid possesses a pungent smell. Okay, and around up to 8 carbon atoms it will be having a faint unpleasant smell, but after that there is no particular odor for this carboxylic acid. Is it clear? So we have seen that up to 10 carbon atoms carboxylic acid generally exists as liquids and the higher members are existing in the form of waxy solids. Second point, we can discuss about solubility. And already we have seen that whenever an organic compound is soluble in water, means they are able to form hydrogen bond with water. So here you can see that this carboxylic acid is able to form hydrogen bond with water. Okay, just see, this is how the hydrogen bond will be forming with water. This is one molecule of water which forms hydrogen bond. This dash we can see as hydrogen bond. Just see, hydrogen bond is formed with carboxylic acid, and that is why we can see that carboxylic acids are highly soluble in water. It is due to their ability to form hydrogen bond with water. But children, as molecular mass increases, that means as you move down in the series, the solubility decreases due to increase in molecular mass. Now the third point, we can discuss about boiling point as well as melting point. Boiling point. In this case, again we can see that carboxylic acid has a tendency to exist as dimer. Okay, carboxylic acid generally exists as a dimer. That is, if you just consider this carboxylic acid, again we can see that they exist as a dimer, and not only that, children, they will be able to form hydrogen bond within the molecule. Is it clear? And due to this ability, they generally possesses high boiling point. They exist as a dimer. You can see that two molecules of carboxylic acid combine together. So that is what it is termed as dimer. So due to this special property, they are having high boiling point. And if you talk about melting point, for example, if you consider pentanoic acid and heptanoic acid, which acid comes in between that is hexanoic acid. You consider the structure of hexanoic acid. That is, when you discuss the structure of hexanoic acid, you can see that they possesses a symmetrical structure. Okay, with one methyl group in one position, terminal position, and COOH group in the opposite terminal position. So they possesses a symmetrical structure compared to that of pentanoic acid or heptanoic acid. That means, children, I want to say that the carboxylic acid with even number of carbon atoms possesses high melting point. Okay, the even number of carbon atom possesses high melting point compared to carboxylic acid with odd number of carbon atoms. And this particular property is termed as alternation effect. Is it clear? It is termed as alternation effect. Here we can say that carboxylic acid with even number of carbon atom possesses high melting point due to their symmetrical structure. And it is because of the symmetrical structure they can be packed properly in the crystal lattice. That is why they possesses high melting point. Is it clear, children? That is about the physical properties of carboxylic acid. Now let us discuss something about their chemical properties. Okay. When we are starting with the chemical properties, the first property we have to discuss is about their acidic nature. Okay, here you know that in order to explain about acidic nature, that is carboxylic acid reacts with water and results in the formation of carboxylate ion plus hydronium ion. Okay. Now when you apply law of chemical equilibrium in this particular reaction, we can say that Kc is equals to concentration of RCO minus into concentration of H3O plus divided by concentration of RCOOH into concentration of water. Or we can say that Kc into concentration of water is equals to concentration of RCOO minus into concentration of H3O plus divided by concentration of RCOOH. Now children, this to Kc into concentration of water, we can consider it as Ka, where Ka is a constant called ionization constant for acid, or Ka is equals to concentration of RCOO minus into concentration of H3O plus divided by concentration of RCOOH, where Ka is a constant called ionization constant for acid. Is it clear, children? So we can say that carboxylic acid reacts with water molecule, produces RCO minus and H3O plus. After applying law of chemical equilibrium, we will get Ka is equals to product of molar concentration of RCO minus and hydronium ion divided by molar concentration of RCOOH, where Ka is a constant called ionization constant for acid. Children, as the value of Ka increases, you know that acidic nature increases. So that is why we can say that compared to alcohols and phenols, the value of Ka is high for carboxylic acid. So they are considered as strong acids, or they are able to turn blue litmus to red. Is it clear? And here we have to consider one more factor, that as the value of Ka increases, acidic nature increases, but the value of pKa will be decreasing. Is it clear? Now again, in order to the next step about the acidic nature we can study in next class. Thank you, children.